Hello students, welcome to our mathematics class. Today we are going to start our second chapter, that is polynomial, and this chapter is a linked chapter. You have also learned different concepts related to polynomial in class 9. So in our first class you will revise those concepts which are essential to learn the new concept present in class 10. So first you will see the definition of polynomial, then examples. Then we will learn about different types of polynomials, and you will learn as per terms and as per degree. Then in the last sessions of this video we will learn the zeros of a polynomial, how to find what is zero and how to find the zeros of polynomials. Let's start the video. As you know, polynomials is a type of algebraic expressions in which the exponent of all variables should be whole numbers. Try to remind these all things that we have discussed in class 9 also, that polynomial is a type of algebraic expressions in which the exponent of all variables should be whole numbers. That means when you are taking some algebraic expressions like x plus 5 or 2x cube plus 4, these all things are algebraic expressions where there are real numbers and also variables. But there are some specific algebraic expressions in which the exponent of variables are whole numbers. Like here the variable x has exponent 1 and here the variable x has exponent 3. So these are whole numbers. So whenever you will see algebraic expressions where the variables will have the exponent as whole numbers, then we can say that these are polynomials. So now we will take some other examples. Suppose I am taking another algebraic expressions 2xyz plus 7. So this algebraic expressions can be called as polynomial because here the variable x has a whole number degree, that is 1, and y has also a degree of whole number, that is also 1, and z has also 1. So we can say that all the variable presents in this expressions has a degree or exponent as a whole number. So we can say that this expression is polynomial. Likewise, suppose I am taking x cube plus 2x square plus 7x minus 9. So here also the variable x in the first term has degree 3 and here degree 2 and here degree 1, or exponent is 3 to 1, that is completely a whole number. And in this case the minus 9, uh, the x has, suppose you will try to write x, then you will mention that the degree is 0. So we can say that all the degrees present here, all the exponents of the variable x is whole numbers. That's why this expression is polynomial. But sometimes you will find some algebraic expression like x raised to the power half plus 5. In this case, we say that this is not polynomial. Why it is not polynomial? Because the exponent of the variable is fraction. So it is not polynomial. Sometimes you may find algebraic expression like x raised to the power of here minus 1 plus 5. So in this case also we say that this one is not polynomial because the variable has degree minus 1, which is negative integers, and in polynomial case the degrees should have always whole number, or we can say non-negative integers. Okay, non-negative integer, that means when the variable has degree 0, 1, 2, 3, 4, this kind of numbers only, we can say that is a polynomial. And if the degree is other than these numbers like negative integers like minus 5, minus 4, or any kind of fractions which is not reducible to whole numbers like half, 1 by 3, or some decimals like 0 0.5, suppose these things are present in the exponent of variables, then you can say that that algebraic expressions does not comes under polynomial. Okay, so now we have discussed about polynomial, and we saw that polynomial is a kind of algebraic expressions where the exponent of all variables are whole numbers, or in simple you can say non-negative integers. Then types of polynomial. Uh, What are the different kinds of polynomial? In class 9 so we have discussed that polynomials can be categorized as per the terms and as per the variables also. First we are going to revise regarding as per the terms. As per the terms, polynomials can be categorized like monomial, binomial, trinomial. These all things are these all types of categories under as per the terms category. So in monomial case, when you in monomial case you'll find that only one term, like 5, 2x, 7pqr, and 9x minus 3xyz. These all things or these all polynomials are examples of monomial, because 5, this is also monomial, 2x, this is also monomial, 7pqr, this is also monomial, as it is only one term. 9x, this is also one term, so 9x is also monomial, and minus 3xyz, this is also one term, so it is also monomial. Then binomial. In binomial you will find two terms added or subtracted. Okay, like minus 5x plus 3. So minus 5x and 3, there are two terms which have been added here, so you can say this is binomial. Likewise you can take x plus 7. So x is one term and another term is 7, and they are added, so it is binomials. So here I have written some terms binomial. You can take this one is 6a raised to the power 4 plus 17x. Okay, and now trinomial. Likewise monomial, binomial, there is another category in that term category, that is trinomial. A trinomial is an expression which composed of exactly three terms. Okay, exactly three terms. Suppose you are taking like a plus b plus c. We can say this is examples of trinomial. Or suppose you are taking a variable of the same category, then x square plus 7x plus 5. So this is examples of trinomial, because it is three terms. X square is one term, 7x is another term, and 5 is another term. So there are three terms. So in this case this kind of polynomials will be called trinomial. And more than three terms you can generally name it as polynomial. Then as per degree, and just we will remind what is the degree of polynomials. We have discussed in class 9 also that degree of a polynomial's degree is the highest or the greatest power of a variable in a polynomial. Remind these things. And the greatest power of a variable. Okay, greatest power, only you have to see the greatest power of the variable. So let's revise this concept. Suppose we have a polynomial like x cube plus 7x square minus 100. So what should be the degree of this polynomial? So in this case you can see that in the first term the exponent of x is 3, and in the second term the exponent of x is 2. So highest degree or the greatest one is 3, so we can say that this polynomial has degree 3. So it is a polynomial with degree 3. Suppose we are taking another example. Suppose 4x square plus 1000x minus 9 raised to the power 8. See this, observe this mindfully. Here the highest degree is 8, but that is not of the variable. It is related to the constant number 9. Okay, so you don't have to consider this. Just you have to consider the highest degree of the variable. So where are the variables? Here x is variables and it has exponent 2, and here x has exponent 1. So highest degree of the variable x is 2 here. So we can say that this is a polynomial of degree 2. Okay, this is a polynomial of degree 2. It's not a polynomial of degree 8, because 8 is related to a constant number. That is the exponent of a real number. But we have to observe the highest degree of the variables only. That's why the highest degree of the variable x is 2. That's why you can say that this polynomial has degree 2. And as per the degree we can categorize different kind of polynomials, like a linear polynomial. In linear polynomials you will find that the variable has degree 1 only. For example, suppose you are taking this kind of equation ax plus b, where a and b are real number and x is the variable, then ax plus b will be the standard form for linear polynomial. For example, 5x plus 7. Okay, so here in 5x plus 7, you can see that 5 and 7 are real number and x is the variable, it is degree 1. So we can say that this is a linear polynomial, and the coefficient of this variable should not be equal to 0, otherwise it will not be linear polynomial. Okay, so in this case you have to you have to mention that the coefficient should be non-zero. Let's take another example. Suppose 7x minus 9. So this is examples of linear polynomial. It is degree 1. X is degree 1. That's why you can say that there is linear polynomial. And for quadratic polynomial like 2x square plus 7x minus 9. So it is example of quadratic polynomial. Here the highest degree of x is 2. Highest degree is highest degree of any variable is 2, then we can say that that will be in the category of quadratic polynomial. Or you can clearly see that in this polynomial the degree of this polynomial is 2, because we take the highest degree of the variable. That's why here we are saying that the degree of this polynomial is 2, and whenever the degree of the polynomial will be 2, it will be under the category of quadratic polynomial. So it is quadratic polynomial. And mind one thing, that x square or any variables which we are taking for its degree, the coefficient should not be equal to 0. Its coefficient should be non-zero. And in cubic polynomial, let's write its standard form. Okay, its standard form is ax square plus bx plus c, where a does not equal to 0. Mind one thing, here a should not be equal to 0. Next, for cubic polynomial, now you can clearly say that cubic polynomial, a polynomial with degree is 3, we can say that that is cubic polynomial, and its standard form is ax cube plus bx square plus cx plus d. And examples, suppose you are writing 5x cube plus 4x square minus 9x minus 7. So in this case a is 5, and this kind of equation, this kind of polynomials, you can cite many more examples. And you have to remind one thing, that when you are citing examples of cubic polynomials, the x cube or any variable you are taking, that coefficient should not be equal to 0. So condition is that, let erase it, we will write the condition just below the polynomial. Condition is that here condition is that a does not equal to 0 in this case. Okay, a should not be equal to 0 to make it cubic polynomial. So as per the degree, we can say that there are different kinds of polynomial, like linear polynomial, quadratic polynomial, cubic polynomial, and you can make other polynomial also as per their degrees. And after watching this video, you will have to cite different examples like monomials. First, you have to write some examples of your own in polynomial category, and also you have to cite some examples which are not polynomial. Okay, at least you will write 5 examples. At least you will write 5 examples. Here give headings of polynomial, and here gives not polynomial, and just write like 2x square plus 3x. This is polynomial. But suppose you will take 2x raised to the power minus 2 plus any number, it will be not polynomial because it is degree minus 2. So in this way, you have to cite at least 5 examples in polynomial category and 5 examples in not polynomial category. Then you have to cite examples, 5 examples in monomial. In every category, just write 5 examples of your own. Don't search it on your net on your mobile. Just try to cite examples from your own mind. Okay, trinomial as per degree, and degree from degree, linear polynomial, quadratic, cubic polynomial. We have discussed these all things, and now you can make polynomials of your own. Then the last sessions, which is very much important, zeros of a polynomial. Zeros of a polynomial. First, first remember what is zeros. Zeros of a polynomial are the real values of the variable for which the value of the polynomial becomes 0. Suppose we have a polynomial x plus 2. Okay, for which value of x this x plus 2 will be 0. For x, suppose we are taking minus 2, then minus 2 and a plus 2 sum is 0. So we can say that for the value of minus 2, the x plus 2 becomes 0. That's why this minus 2 is 0 of x plus 2. Okay, zeros of a polynomial are the real values of the variable for which the values of the polynomial become 0. That means here whenever we will take x equal to minus 2, for in this case x plus 2, the x plus 2 becomes 0. That's why minus 2 is 0 for x plus 2, because when we put x is minus 2, it becomes 0. That's why this one is 0. Okay, minus 2 is a 0 for x plus 2. Let's see other example. Suppose we have x plus 7. So what should be the zeros of x plus 7? You can say that for x, suppose we will take minus 7, then we will get 0. That's why we can say minus 7 is 0 for x plus 7, the polynomial x plus 7. You will see some other examples how to find the 0. Yes, now you can see the questions. Find the zeros of px, that is 5x plus 4. 5x plus 4 is our polynomial and it has been named as px or p of x. Then now we will try to find its 0. And the process of finding zeros of any polynomial is just you have to equate that px 0. That is, to find zeros of px, we need to equate px equal to 0. And likewise here we are equating px equal to 0. That means 5x plus 4 equal to 0. We are trying to find the value for which this polynomial will be 0. So let's transpose the constant number first, that is plus 4, to the right side, that will be minus 4. Then for 5x, you know that 5 is coefficient which has been multiplied with x. That's why when we will transpose 5 to the right side, it will be divided. So x equal to minus 4 by 5. This is the solutions for this equation. But for the polynomial, you will say minus 4 by 5 is the zeros for the polynomial. Okay, minus 4 by 5 is the 0 of the polynomial 5x plus 4. That means when we will put minus 4 by 5 in this position, or in the in place of x, it becomes 0. Let's try this. 5 into this is minus 4 by 5. Okay, in place of x we have write the value, and it is 4. Minus 5 cancel out, then minus 4 plus 4, that is 0. So minus 4 upon 5, when we will take in place of x, the polynomial becomes 0. So we can say that the value minus 4 upon 5 is 0 for the polynomial px. And this is the step. Whenever you will be given a linear polynomial or an quadratic polynomial, you will follow this step. To find zeros, just you have to equate px equal to 0 and you will find the value of x. And for any linear polynomial ax plus b, its 0 is minus b by a. Okay, its 0 is minus b by a, and you can verify this by taking this kind of steps. For linear polynomial, the 0 is minus b by a, and you have to mind that this a should not be equal to 0. Okay, that is non-zero coefficient. And note that for MCQ questions, this is very much important. Let's see one example for quadratic. Here we are taking a quadratic polynomial x square plus 5x plus 6. And how to find the 0? The same process. To find zeros of px, we need to equate px equal to 0. That means we have to show px equal to 0, and we will try to find for which value of x the px is becoming 0. And x square plus 5x plus 6 equal to 0. This was the polynomial. We have equated it to 0. And you know that in quadratic case, we try to find two numbers such that their sum should be here in this case 5, and the product should be 1 into 6, that is 6. So these two numbers are 2 and 3, which sum is 5 and product is 6. So you will try to break 5x as 2x plus 3x, and you will take common x from the first two terms, and to make same factor on the last two term, we will take the common 3, and you will get x plus 2 and x plus 3. These are the two factors that we are obtaining from the x square plus 5x plus 6. And on the last stage you will equate x plus here x plus 2 and x plus 3, both are the factor. We can say that either x plus 2 is 0 or x plus 3 is 0 or both are 0. So x plus from x plus 2 equal to 0 you will get x minus 2, and from x plus 3 equal to 0 you will get x equal to minus 3. That means x equal to minus 2 and x equal to minus 3, we are getting two solutions of this quadratic equation. But for the polynomial you will say that the minus 2 and minus 3, these two values are zeros for the polynomial, that is x square plus 5x plus 6. Minus 2 and minus 3 are the zeros of x square plus 5x plus 6. When we'll put the value of x as minus 2 in this polynomial, it will become 0, and also when we put minus 3 in place of x, it will become 0. That's why minus 2 and minus 3 are zeros of these polynomials. So this was all about the zeros of linear polynomial and quadratic polynomial. To find the zeros of linear polynomial, it is very simple, and in case of quadratic polynomial you just need to think some numbers, and the different approaches we will learn in next classes. But this simple approach, now you can use this simple approaches to find zeros, and I will give you some tasks at the end of the session. And you have to remember one thing: for linear polynomial, number of zeros, number of 0, that will be 1. You will get only 1 0. But in case of quadratic polynomial, uh, you may get two zeros. Okay, you will get 2 0 that may be distinct or that may be unique, but you will get 2 0. When there will be real zeros, you will get 2 0 that may be same or that may be different. In this case, here you may get same numbers or you may get different numbers, but there will be 2 zeros. So let's see the task. So this one is your homework for this day. First thing, you will write examples in each category. Then at last you will try to find the solution. You will find the solution of this question, that is find the zeros of 2x minus 4, 7x plus 6, 9x minus 4 upon 3. So these are the polynomials. You will find its zero. So it was all about today's class. In next class we will discuss more about this.